Alright guys, today we're going to be doing 4.2, two proof-oriented triangle theorems. The theorems that we're going to be focusing on today are the no-choice theorem, as well as the angle-side postulate. So those are the two things that we're going to be focusing on. Our learning target today is I can prove triangles are congruent by angle-side. So a new triangle postulate that we're going to be using. So to get started, let's go ahead and start off with the no-choice theorem. The no-choice theorem states, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. So with these two triangles here, we have angle A being congruent to angle D. We have angle B being congruent to angle E. And if that's the case, well, we know that there's 180 degrees in each of these triangles. So therefore, angle C must be congruent to angle F. And that's what the no-choice theorem states. If two angles are congruent to each other in two triangles, the third angle must be congruent to each other. And that just goes back to there being 180 degrees in a triangle. So, as an example, let's say that angle A is 80 degrees, and that would mean angle D is also 80 degrees. Let's say angle B is 40 degrees. And if that's the case, then angle E would also be 40. Now, from here, we have 120 degrees between two angles. I know that there's 180 degrees in the triangle. So as a result, if I already have 120 degrees, that means that this third angle must be 60 degrees. Because as we proved in our last video, there's 180 degrees in every triangle. So as a result, both of these angles must be the same. And that is the no-choice theorem. Now, along with this, we can see that these two triangles, triangle ABC and triangle DEF, these don't look to be the same triangle. They don't look to be congruent. AC seems to be longer than DF. So it is important to note that triangles do not need to be congruent for the no-choice theorem. This just goes into similarity, which we'll cover more later on in the course. But all similarity is stating is that two objects have all the angles being the same, but none of the side lengths are the same measurement. So they're ratioed, essentially. They have a ratio in which you can multiply or divide to get to the other shape. It's the same as dilation. All right, so that is the no-choice theorem. Next up, we're going to have the angle-side postulate. So two triangles are congruent if two angles in a non-included side of one triangle are congruent to the corresponding parts of the other. So here we have two triangles, triangle ABC and triangle XYZ. And we see that angle A is congruent to X, angle C is congruent to angle Z, and BC is congruent to YZ. Now, we have this term non-included here. And non-included just means that it's not sandwiched in between the two angles. It's not included in between them. It's on the outside. So whenever you see non-included, that just means that that side is not sandwiched in between the two congruent angles. It's not included with the two congruent angles. It's on the outside of it. So as we can see, triangle ABC is congruent to triangle XYZ by angle-side. And that is our theorem. Now we're going to go ahead and prove this in just a second, but again, make sure as you're going around these triangles that you're reading the congruency marks. So angle congruency mark, angle congruency mark, side congruency mark. Now you may be wondering, couldn't I go angle, side, angle? Well, no, because I can't go past a side and an angle without congruency and say that the triangles are congruent. So I'd have to go angle, okay, there's no side congruency, but there is an angle congruency. So I go in that direction. I wouldn't go towards the direction that doesn't have a side congruency or an angle congruency up next. I'd always go towards whatever has a side or angle congruency next. So just keep that in mind as you're going through. Now, we're going to go ahead and prove this now. And this is a very short proof, but the key here is that we cannot actually say that we are proving it by angle-side, because what we're given is angle-side. So we're going to prove this by another triangle postulate. And if we can do that, then we know that angle-side will always work for us. So we go ahead and we start out with our given. Angle G is congruent to angle K, angle H is congruent to angle M, and segment JH is congruent to segment OM. Again, we want to prove that triangle GHJ is congruent to triangle KMO. So, at this point, we already have two angles that are congruent in both triangles, and their corresponding angles, which means that we can say that angle J is congruent to angle O, And we can say that because the no-choice theorem, the theorem that we started today off with. If two angles in one triangle are congruent to two angles in another triangle, then as a result, the third angle in both triangles must be congruent, and that's by the no-choice theorem. Now, at this point, we go ahead and we look at our triangle and we see if we have any other triangle congruence besides angle, angle, side. And if we look at this, we have angle, purple, side, red, and angle, green. So we have angle, side, angle. That is another triangle congruency postulate that we already know. So therefore, we can say that triangle GHJ is congruent to triangle KMO, and again, that was by angle, side, angle. So that's why we can say that these two triangles are congruent. Now, as a result, since the two triangles are congruent by angle, side, angle, that means that angle, angle, side is a triangle congruency postulate. So now we can use angle, angle, side whenever we see two triangles that have two angles in the non-included side congruent to two angles in a non-included side in another triangle. So again, this just allows us to use it all the time because we were able to prove it with another triangle congruency postulate. All right. Lastly, we're going to go ahead and determine if triangles are congruent by angle, angle, side. So make sure that you're focusing in on the congruency marks and make sure that you're reading around the triangle's edge. So again, we're reading around the edge of the triangle for congruency marks. So determine if the two triangles are congruent by angle, angle, side. Now, for this one, if we look at the two triangles, of course we can read the congruency marks. We have angle, side, angle. So obviously this one's no. One side is angle, side, angle for one triangle. The other one has angle, angle, side. So if this side was not included, if it was on this side, or sorry, this leg of the triangle, then these two triangles would be congruent by angle, angle, side. But since the side is included between the two angles, we would say no. All right. Next up, we have these two triangles. Are these triangles congruent by angle, angle, side? Well, looking at this, we have angle, angle, side. We have angle, angle, side. However, the angles are not corresponding to the correct angles. So this would be no. Corresponding parts don't match. We have one congruency mark up here, two congruency marks over here. So again, pay attention to how many congruency marks because that's how we can tell if those angles are congruent. Our final one. Are these two triangles congruent by angle, angle, side? Well, if we look at this, we have angle, angle, side, and angle, angle, side. But you may be wondering, doesn't this look strange? Well, yes. One of the angles is reflected. So we can say yes, these both have angle, angle, side, but a reflection of the triangles is occurring. And that's what makes it so that it doesn't necessarily look like it's angle, angle, side. However, if I were to reflect it across this red line here, these triangles would have the same orientation and they would be congruent. So yes, these two triangles are congruent by angle, angle, side. All right, so that's it. That's all we have for today. Again, very short lesson. If you guys have any questions on it, please leave it in the comments below or contact me. Other than that, have a great rest of your day, guys. Thank you so much for watching. Take care.